Okay, so we're having a look at the 12 times table today, and we'll just sort of go through them one by one just so you get the idea. Some of them are going to be super easy. 1 times 12, you don't need to really memorize that one. You know that it won't be anything, and that's something we've discussed many times before. 2 times 12 is just double 12, 24. You've probably seen that many times before. 24 is one of those numbers that has lots of ways to make it. So you can go 3 times 8, 2 times 12, 6 times 4, that sort of thing. So 24 is a number that appears lots and lots. Same with 36, it's a number that appears a lot. Up to here, these first 4 are really easy to remember because this is clearly 12 plus 12 plus 12 plus 12, that sort of thing. So the first 4 usually are not that hard. Makes sense, and you'll start to see patterns in here too. So you've got 2, 4, 6, 8, 0, 2, 4, 6, 8 and the last numbers as well, because it's 10 plus 2, right, is 12. So that pattern continues all the way up. 5 times 12, you know from the 5 times 12 is 60. 6 times 12, you've encountered that in the 6 times table that you've been doing before. But it's a good one to remember. So this is one that we can spend a bit of time memorizing. The first sort of 5, they're not too hard, are they? They're pretty good. Then there's a few others that get a little bit meaner. 7 times 12 is 84. You sort of think, with a 7 in it, how does it end up to 84? But it makes sense, because if I add 12 onto 72, I get 84. So this is one that's worth memorizing. 8 times 12, same sort of thing, comes to 96. Makes sense when you think about it, because you've got 8 sets of 10 plus 16, so that's one that's worth having a look at. 9 times 12, this is one of our class favourites because it's the sort of thing that almost always ends up in tests. Have you encountered that? Yeah. They love putting in tests. They say there's no 9-year-old in the world that's ever going to know what 9 times 12 is, but we know it's 108, so we're gonna beat them at their own test. Yeah. 10 times 12 is easy because anything times 10 really just glue. It's a bit like gluing that 0 on, isn't it? So you're changing its place value from 12 ones to 12 tens. Easy. That one's a nice easy one. This next one confuses people. 11 times 12, but as we learned from the 11 times table last week that we did. If you add 1 and 2, you get 3 in the middle. Makes sense, right? Yeah. That's in the 11 times table. And then the last one, this is a bit of a class favourite. In fact, it's probably worth memorising that one, actually, to be fair. And this one's a class favourite. 12 times 12 is 144. People like it because it's the last one in our normal 12 times table. So it's worth memorising. It comes up a lot as well. Now, people might ask, why do we still learn up to the 12 times table? Surely, just up to the 10s would be fine. And that's a really valid question. Why do we learn up to the 12 times table? Well, up until fairly recently, historically, you really needed to know your 12 times table so that you could work with pounds and ounces, that you could work with shillings and pence. Old-fashioned money and old-fashioned measurements used 12 a lot, and 16 and 20. And the reason they use 12 instead of 10 is because it's easier to chop up, right? So half of 12 is 6, a quarter of 12 is 3, a third of 12 is 4. So it chops up nicer, it makes nicer fractions than 10 does, and that's why they use 12 a lot in the past. And learning up to our 12 times tables is something that we've just carried on doing.
Could we learn up to 15?
So the skill that you learn by learning your 12 times tables is something that you can use for bigger numbers as well. And this is what Sophia was just mentioning. She says, can we learn up to 15s? Yes, you can. Use the same trick that we use for the 12s to go your 13s, 14s, 15s, anything you like really. And the trick is this. I'll show you that in a second. So you've got that down on your things? Okay, good. All right, we'll just pause this for a second. Okay, so the trick is to do with the fact that 12 is 10 plus 2. Well said, Sophia. 12 is the same as 10 plus 2. It's like a regular maths question. Have you seen maths questions done backwards like that? Yeah. Think of equals like the pivot point on a seesaw, exactly. So on a seesaw, if I had, I don't know, 12 oranges and then 10 plus 2 oranges, they would be the same. They would balance out, right? So that's all that equals means. It's like the pivot point. So whenever you say equals, what you're really saying is it's the same as what's on the other side of that symbol, right? And 10 plus 2 is the same as 12. Yes?
Did they used to have a monkey thing and it's kind of like a scale where you put bananas on one end of the hand and then bananas on the
That's exactly the sort of thing. Yeah, it's a balance, isn't it? And we can use that trick to help us figure out tricky 12 times tables. Okay, so we can use that trick of 10 plus 2 to help us figure out a whole bunch of tricky times tables that we find hard. My confession is that basically from 6 on, I don't really memorize it. I haven't memorized it. I try to. The more I do it, the better I get at it. But sometimes I get stuck. Say something like 8 times 12, right? And you can see up there the answer is 96. But what if I couldn't remember on the fly? Maybe I'm going, oh, I need to know what 8 times 12 is, and I've just completely forgotten. It's fallen out of my head. If I split this into 10 plus 2, suddenly it becomes easy because I know that 8 times 10 is 80, right? That's really easy. I don't have to think about it even.
Like 92.
And then I know that 8 times 2 is 16. Good, exactly. Then I can add those together really quickly and I get 96.
What if you don't
And it's a super handy trick that you can use if you're finding you're getting a wee bit stuck with some of these, or if you get a harder one. But for these ones, really, really handy because you know what the 10 plus 2 is. Okay, you could use it for harder ones. Say, you wanted to do. Well, we'll use Sophia's one. Say we want to do even 15 times 12. All right. Some of you might have the answer in your head already. That's fine. But think about it along the lines of splitting it into 10 and 2 again, and it suddenly becomes really easy, right? So if I say, well, I know 10 times 15 is 150, I've got that without even really thinking about it. I can use place value, makes it easy, right? Yeah? Nice to see a few nodding heads there. And then double 15 I know is super easy because I do that all the time, it's 30. Suddenly it seems really easy. 15 times 12 is 180, exactly right. So it's a really handy dandy trick. It's called a part-whole strategy where you can see the whole number but you split it into easier to deal with chunks and then glue it back together. It works with other things. I could do it the other way around too. Say if I was multiplying by 15, and this is Sophia's earlier question, if I was multiplying by 15 I could use exactly the same strategy. So if I wanted to go, I don't know, just randomly 9 times 15, I could use exactly the same strategy and say, well, I know 9 times 10 is 90 and I know 9 times 5 is 45. I can glue those two together and get 135, right? And how do I double check that it's in the 9 times table? I just add up all my digits, 1 and 3 and 5 comes to 9. Yep, that sounds like it's the right answer. Okay, so the trick here really isn't to do with the 12 times table. We do use it in the 12s, but it's splitting your number so that you can deal with easier chunks. And so 12 just happens to be the first time it's really useful. We did a little bit last week with 11s. Remember how we split it into times 10 plus times 1? It's even easier. This is just like that. It's just times 10 plus times 2. It actually makes it quite an easy strategy for you to have. Can you use the regular algorithm to do the same thing. Say if you wanted to multiply by a very large number, no, 784 times 12. Seems hard on the surface, doesn't it, guys? You're looking at it, you go, oh man, 784 times 12, that's just mean. Well, you can fairly easily do it by using the 10 and 2 trick again. So remember, when we're multiplying by 10, we kind of put a placeholder on there straight away. Then we can just we can do the times 10 first. Super easy. Just copy down 784 there. So I've already done half of it. Now all I have to do is double 784, which isn't difficult. So 2 times 4 is 8. 2 times 8 is 16. Carry that one up to there. 2 times 7 is 14 plus 1. Then I can add those two together. Am I still in the shot? Yeah, good. So I've got an 8 there and a 10 there. Carry that into the hundreds. That would be 6 and 8, which is 14, which gives me another 1,000 to put up there. And I've got a total of 9,408. And it's just, all you're doing is splitting the 10 and the 2. It's exactly the same strategy, but it's just a little bit harder because you've got a bit more to do, but the strategy is the same, splitting it into 10 and 2. Does that make sense?
Yep.
Yeah, I've kind of rushed through it. We will spend more time doing this, guys, so don't panic if you don't sort of see how it works straight away. We'll come back. In the meantime, though, we'll practice our basics. So well done. Thank you for listening, guys. Appreciate being nice and quiet during the video. You can pause the video here and have a go at these questions. I'll put the answers up in a second. Okay, so we know the 10 and 2 trick. It's splitting 12 into 10 and 2. Can we do something similar just using our 12 times tables? Well, absolutely we can. So say we had a bigger number, like 8,527. We want to multiply that by 12, right? Now, to do this next one, it's really handy to know your 12 times tables off by heart. Memorizing your times tables makes it a lot quicker. Traditionally, we've learned that we can split this 12 into 10 and 2, and you can still do that if you get stuck, because it does make it quite simple. In this case, though, I'm going to say, well, why don't we just deal with this whole 12 all at once? And of course we can, but we do need to remember our 12 times table. So I'm going to get you to give me a hand, because I think, well, sometimes I'm a bit shaky, but I know you guys have got good memory, so we'll see how we go. Who can tell me what 12 times 7 is? 12 times 7. You did it yesterday. What do you think?
14.
Not double 7. 12 times 7.
12.
Okay.
6.
Not 60.
72.
84. Give that man a high five. He's absolutely right.
He doesn't.
84. So in the same way that we usually do. Thank you. We put the 4 down there and the 8 up there. 84. Same as we normally do. You guys will know this one. 12 times 2. 24. So then we add this little guy up here. What is 24 plus 8? 32. Good. So we'll put the 2 down there. It's the same method that you've encountered before, but the numbers are just slightly bigger. Now you must remember 5 times 12, it's in the 5 times table. 60. Then I add this little guy here, it comes to 63, right? One of our favourites, 8 times 12. 8 times 12. Jackson?
108.
Not quite.
144.
No, it's less than 108. What do you think?
90.
You're on the right track? It's pretty exciting. It's like a game show.
98.
Really close, a little bit less.
What's next?
Somebody's got it. 96, exactly right. So 96. Then 96. Listening? Okay, so we've got 96. Then here's a little. You're going to have to go over the 100 to get this. 96 plus 6. 102. Now, in this case, thank you guys, we're just going to put all of 102 right there. So we end up with quite a big number, but it makes sense because we're multiplying basically 8,500 by 12. We end up with 102,324. When you're multiplying by 12, you end up with quite large numbers straight away. Okay, so, thank you. So, on the sheet that I've got for you, you've got some of these we're using the 10 and 2 trick. You've got some of these we're using the whole multiply by 12 trick. Now, as you work through it, what you'll find is that the stuff that you do at the very start, the simple ones at the start where you're just doing your 12 times table, will help you to do these ones because you can refer to that bit at the start. Does that make sense, guys?
Yeah, kind